Yo, what's going on, everyone? You're welcome once again to David Data channel, and I'm excited to have you on my channel here again today. On today's video, we're going to be talking about conformed dimensions. Conformed dimensions is the concept that is prevalent in the Kimball dimensional methodology of your data in your data warehouse. In our previous videos, in our modeling series, you can find that in the link below and the link in the description above as well, where we talk about the basics of Kimball dimensional modeling, talking about facts and dimensions. And today's video, we're focusing on conformed dimensions. But before proceeding into the video, if today is your first time or you're a returning viewer, I'm so happy to have you on this channel. Please don't forget to hit the like button and the subscribe button and also the notification bell so you can be notified once a new video drops in on this channel. Yeah. Alright, so let's jump to our screen. Now, what are conformed dimensions? Conformed dimensions really are dimensions that can be used across different facts or different processes. Now, understand that your business is made up of different processes. Say an e-commerce business, for example. Your e-commerce business has several processes within the business. So there's the orders process, the shipping process, the returns process, the sales process. All these processes are standalone processes that could work with maybe different departments, right? But then all these processes come together to form the business as a whole. Now, typically, dimensions allow us to drill up or drill down in our facts, right, as it were. But conform dimensions, because they can conform within different facts or different business processes. It allows us to drill across different facts or different processes. Now, let's say think about a certain big process. Let's say an orders process. So you have your orders that comes in every day, and then you have your inventory process. And you say for your business, my inventory process is only stocked every month. So that means you on your inventory what's it called, on your inventory process or your inventory fact and your orders fact. So they will probably have different date dimensionality. So your orders may have a daily date dimension because orders are coming in daily, but your inventory will be on a monthly basis. Now, conform dimensions allows you to drill across these two facts or these two business processes, even though they may not necessarily have the same granularity as it were all the time, right? So conform dimensions are really important because they help you to break down silos in your data warehouse when you're developing your data warehouse. Say, for example, on our screen right now, why conform dimensions? Let's imagine we have the orders process, and then we have the returns process, and then we have our orders facts, and then we have our returns facts as well. And then while you are modeling your data in your data warehouse, you decided to build a star schema for your orders facts and to build a star schema for your returns facts. So beautiful, all looks good and fine. There's your date key, your sales rep key, your customer key, your product key, and then for your returns, there's your date key, your sales rep key, your customer key, your product key, and your quantity. And this should be quantity returned. Quantity returned. All right. So, and then you have your date key to your date, sales rep, customer, products, and you have your measure. And then you have your date key, same thing here, sales rep key, customer, product, and your quantity ordered, which is your measure. Now, interesting stuff. So imagine we wanted to drill across these two facts or these two processes. Let's say wanted to get number of products that were returned by number of products returned, basically, right? Number of products that are ordered and then returned. And so if you decided to pick to use your order star for this information because you have everything in here, you will probably not have every information as the people in the returns department or the returns star schema would do this, because eventually it will just say want to compare the product table. So at this point we are trying to just compare only the product table in these different star schemas, in these different business processes. There's the order department and the returns departments, right? And then let's say you have products with q 11A and 11A as well. So if you look at this thing critically, you notice that there are some differences between these two product tables in these different star schemas. Both of them are supposed to be products, both of them are supposed to align for the whole business, but then the orders team are keeping their own product table, the returns team are keeping their own product table. Now, you don't want to model your data in your data warehouse like this because you're going to be creating silos even in your data warehouse. And then these are some of the disadvantage of this kind of modeling, and this is where conform dimensions shine, as I will explain as we proceed further. Now, looking at it, there are some differences. Um, for example, this return star product table contains the type dimension, right? But on this guy, there's no type here. So if you decide to get a number of orders, get quantity ordered from this quantity of products ordered from this product table, right? Using this orders fact, and you are asked to group by type, you wouldn't have type in here, right? And then if you said you wanted to join with this other product table, so I'll start showing you some of the issues that you may eventually have. Now, another issue is that columns that appear to be the same are named differently. So there's product Q, that's fine. SKUs Q, that's fine. Then products here, we have product name here. And then we have category here, we have products prod category here. And then we have type that does not exist here as well. And then building across now becomes difficult between these two business processes. So you want to find out something about the orders relations to returns, and it has to do with products. Because these two processes are keeping standalone product tables for each of their star schemas, it becomes difficult for you to drill across these two business processes. Now, it's possible to work around this kind of issues, but then it becomes it can be avoided, right? And then names are not consistent, and it's possible. And look, for example, let's say it's Q111, Q111Z. Here on the other star is called clock type A. On this guy is called clock, right? Q11C, here is called standard Niven. Here is called Niven, right? And if you notice that Q11Z, the surrogate key at this point changed. It was 1124 before, and now surrogate key is 1143. So it's possible that there was a change of these Q products 111Z, and possibly other star used a type 1 SCD, school chain dimension methodology. It overwrote the whole thing, the old one. And then these products return star schema use type 2. So you begin to see some discrepancies here and there. Another issue we have is that type 111Z has two records here, but then it has only one record, like I mentioned, probably because this guy was changed, and this return star product table kept a record of the changes. This guy overrode the changes. And then we have that 111F exists here but does not exist here. And then you have that 111E, they both have 111E as well. On both tables, they have different surrogate key. Now, this can be work around, right? You can actually work around this, right? You want to, yes, but then what's the point? Having to do unnecessary stuff when it can be avoided from your design phase. That's the goal of your dimensional model, to help you design your data warehouse from scratch in a way that is scalable for the business. Now, this is where the conformed dimensions shine, because you say that if my dimension can be used across different business processes, then we can as well have a conformed dimensions. And one of the easiest way to understand the conformed dimension is by using the boss matrix, right? The boss matrix. So let's say we have a business process here. Let's call this a business process. I'll just try to explain this quickly. We have a business process: retail sales, orders, inventory, returns, and shipping. Right? These are several business processes. Instead of creating a star for retail sales, a star for orders, a star for inventory, a star for returns, a star for shipping, you do your boss matrix, identify dimensions that are conformed, that can that when I say conformed, means they are what's the grammar now? They are applicable to the other business processes. So let's look at date, for example, right? Date is applicable on retail sales, orders table, inventory, shippings, and returns. So why do I have to create a dim date for a dim retail sales date, a dim orders date, a dim inventory date, a dim returns date? No, I just have one date dimension, and it conforms, or it can be applied to these other business processes, right? I have my product dimension as well. So retail sales uses products, orders uses products, inventory uses products, returns uses products, shipping uses products. So instead of having a special product table for retail sales, having a special product table for orders, having a special product table for inventory, or having a special product table for returns, I just have one product table that conforms or joins all these products all these products in all of these business processes into one central product table, right? This is how you should think about designing your data warehouse, so that your data warehouse is not beginning to have silos based on your business processes. This is on a very basic level, right? And then we have store as well. So for store, there's conform dimensions for retail sales, inventory, and shipping. So I can have one store dimension table for my retail sales, inventory, and shipping. For my customer as well, I can have for retail sales and returns. For my employees, I can have one table for my retail sales, my inventory, my returns, and my shipping. So basically, this is really what conform dimensions is all about. They're there to help you see that from your extraction, transformation, and loading, you have one master dimension that helps you control, that helps you apply that single dimension table to several facts or several business processes, as the case may be. So, if you're designing a data warehouse for your business, for your team, for your organization, always bear this in mind that you can do conform dimensions using your boss matrix to identify dimensions that are consistent across different facts or different business processes, so that you have a single dimension for several business processes and don't create a data silo of stars within your data warehouse. All right, so I hope this video made sense to you and you gained a thing or two out of this video. Please don't forget to drop your like. Yes, your like. Don't forget to also drop your comment section in your comment rather in the comment section below. I'm excited to hear your thoughts about conform dimensions as well. All right, so thanks so much for watching. Bye and see you in the next video. Bye bye.